Greetings, Saintsmen. We have lesson 5.3, which is proving triangle congruence via SAS, which SAS is an acronym for side angle side. So if we have two sides and the included is the key word, included angle of one triangle are congruent to two sides and the included angle of another, and the triangles are congruent. All right. So, what we need to do here is discuss this, which we're gonna give this to you guys via postulate right now. It doesn't take further proof. And the reason that this I'm gonna give this to you guys as a postulate has to do with construction that we're going to complete in class. We are going to do the SAS construction in class. So make sure that you bring your compass to class. All right, so here we go. Let's actually do this proof. So let's draw this triangle, and then I'm going to draw this out, what's called an altitude. So it's this perpendicular height. So this is our triangle A, B, C, D. These are marked. So what we have marked with it. And then here is what the proof says. So my given is that B is the midpoint of AD, and that angles ABC and CBD are right angles. And what we are going to prove is triangles being congruent. We're going to prove that we have these two triangles here, ABC. And it's going to be congruent to triangle CBD. Now, I hope you guys have some intuition here that these two triangles here, right, this guy and this guy, are both going to be congruent. Somewhat of a visual. But we need deductive proof that this is the case. All right, so been through this before in class where we actually did some proofs, and we were trying to show that all six parts of the triangle here, of the two triangles, three angles and three sides were congruent. Now, we don't need to show all the angles and all the sides are congruent. Now, with the limited amount of information, we're going to show more is less. Okay? Okay? Rather than show that all six parts, three sides and three angles, are congruent, we now need just three congruence statements. And it's going to be some sort of combination of sides and angles. In this case, we need two sides and one angle. Now, the angle has to be included, has to be included. And this is something I can't stress enough when we get into class. There is no angle side. The angle has to be in between. It's going to be sandwiched in between the two sides. So we have our statements, we have our reasons. We have number one, which is B is the midpoint. AD, and then angles ABC and CBD are right angles. So just restating this, which is given to us. Now, step two. What does this mean? Well, let's go ahead and take what's given and see what else we can conclude based off of that. First thing is that B is a midpoint of AD. So what does that further lead to? That this is halfway in between A and D, meaning that what can we conclude about A, B, and BD, right? Because total, I need three congruent statements. Right now, I've got none stated here. So our first one, we want to show that AB is congruent to BD. Okay? And that right there is the definition of the midpoint, right? Remember our reasons here. What goes on the right side? Properties, postulates, definitions, and theorems. So we have a definition there, the definition of a midpoint. So that's the first one. Next, we have these angles, right? This angle and this angle. Oops. Oh no. So these two angles that are adjacent to each other, there's a linear pair. So we're going to say that angle ABC is congruent to angle CBD. Now, it's not stated that way. It's just told that they're right angles. So, of course, they're going to be congruent to each other. Why? Well, this is a reason that we discussed earlier in the course. All right angles are congruent. Okay, this came up previously in one of our proofs. All right, so right now, I've got 1, 2 congruent statements. Remember what I need. I need 3. So, I've got this guy right here, congruent to this guy right here. So, remember what we said is that we have to have our angle sandwiched in between our sides. So here's one side right here. Here's our other side right here. So the angle's now sandwiched in between, and it's BC shared by both of these triangles. So we can say that BC is congruent to, of course, itself BC, which we know which property this is, right? Now we need to be able to state it because we needed 3 of these congruent statements. And this, of course, is kind of that silly reason, that silly property that we saw previously, which is the reflexive property. So BC is congruent unto itself. So we're actually all set here. We now have enough information by showing that we have just 2 sides in one angle, as long as the angle's included in between the 2 sides, right? This guy is what we mean by included, sandwiched in between. So we have triangle ABC congruent to triangle CBD. We must have this piece of notation, the triangle, to actually show it's a triangle. And this is through SAS, or side angle side. So now when we're proving triangles, right, this is our final step. Remember, this should be the final step of the proof. And all of our answers are going to be 3-letter reasons when we finish for triangles, including there's one that there's kind of an exception, but it's also technically a 3-letter reason. Okay? So let's do another one. One more of these proofs. Again, this is kind of what we talked a lot about before with Michelangelo, the Sistine Chapel. We're going to have to stare at the ceiling a little bit sometimes on some of these. You're going to have to be a little bit creative. All right. Here is our diagram. We have a quadrilateral that has 2 diagonals drawn, intersecting there at point T. And then these outside points R, S, P, and Q. And what we're going to be given is the following, and then we'll mark our diagram based upon that, is that we have RT is going to be congruent to TP. Moreover, that we have ST congruent to TQ. All right, and we're going to prove 2 of our triangles congruent, which is going to be triangle PTS and triangle RTQ. Now, remember what we talked about previously, which was the dialectic, talking this out with each other. So, step 1, let's actually create our 2-column proof. Okay, let's set up our 2-column statements on the left, reasons on the right. And then, of course, let's always know that we can do step 1 together, which is restating RT being congruent to TP and ST being congruent to TQ, which is given. Saintsmen, this step right here, everybody can do, all right? When you have to do a 2-column proof, if you can do nothing else but to copy this directly, this verbatim goes in for step 1, right? That's what we need to do, and you'll get some sort of partial credit for your proof. Again, I said that I think sometimes it's like putting your name on your paper. It kind of breaks the dam that you have with like a writer's block. Now let's get the logical juices flowing here. Let's mark our table, our diagram, right? RT congruent to TP. So let's put those congruence marks. Then we have ST congruent to TQ. Okay. And then now let's check out what we're trying to prove here. We're trying to prove that PTS, it's this triangle, and RTQ, this triangle, are congruent. Well, what do we know about these triangles that I just actually sketched out there, right? Don't we see these angles that are, and it's this guy's going to be the hint. What's the only thing we have to work with but side angle side to show that these triangles are congruent? Well, can we prove that this angle and this angle, which are the ones that are included, sandwiched in between, angles, these two sides, right? Can we show that they're congruent? But of course we can. So we have angle RTQ, right, which is going to be congruent to STP. And for kind of an old school reason, something from chapter 1, these are vertical angles. Awesome. So effectively, we've done our job. Now, do I have 1, 2, 3 congruent statements? Go back here. Remember what I had here. I had 1, 2, 3 congruent statements before I could show that my triangles were congruent. So yeah, here we go. I have triangle PTS, which is congruent to triangle RTQ. And again, it's actually no surprise as you do these proofs, we pretty much only have one way, one final reason. So we're kind of almost trying to look for and set up these a certain way. Now, we're going to have more triangle congruence um, uh, reasons, right? We're going to have other ways to do this, but it's going to be consistent with these three letters. For now, we just have an angle included between two sides. So remember, bring your compass, and I will see you guys in class.